to divide both sides by 16, which will give me 1/16 du equals x dx. I can replace everywhere I see an x dx appear with 1/16 du, because that's what x dx equals. The u is equal to the 8x squared, so I can replace the u that's up here with that. So the only thing that's staying is the integral symbol and the cosine function. Everything else is getting replaced with either u or 1/16 du. So let's go ahead and do that. So my integral becomes cosine of u, which is 8x squared, and then, no, cosine of u. I want u now. I'm doing this substitution. Cosine of u, and then the x dx gets replaced by the 1/16 du. So we've substituted this integral with one that's simpler for us to calculate. So I'm going to take 1/16 times the antiderivative of cosine u. Well, the antiderivative of cosine would have to be what? Sine? Sine u. And then we need a plus c here. Don't forget the constant, even though nobody likes him.
Would it be cheating if before the constant was here, I write plus c on my hand?
All right, so now we just resubstitute back u. So u is 8x squared, so I could write 1/16 sine of 8x squared plus c, and that's all we need. If you want, for clarity, we can put parentheses here. And maybe we should. We'll pause here for questions. Number 6, they don't tell us what u is. I need to pick u so that when I take its derivative, I see that somewhere else. I see an x to the 6th. If I take a derivative of x to the 6th, I'm going to get an x to the 5th, which is good. So I want u to be that x to the 6th term. So u is going to equal x to the 6th minus 5. The thing inside what's being raised to the 4th power. So the derivative here would be du is equal to 6x to the 5th dx. I don't see a 6 to replace, so I've got to get that to the other side. So I'm going to have 1/6 of a du is equal to x to the 5th dx. This is great because I have an x to the 5th dx to replace. And now I have something that's equal to that can be replaced. So we'll write our new integral. Instead of this binomial to the 4th power, I just have u to the 4th power. And then we're replacing x to the 5th dx with 1/6 du. And we've got an integral that's easier than the one we started with using substitution. We'll go ahead and evaluate this integral. I've got 1/6 times the antiderivative of u to the 4th, be 1/5 u to the 5th, plus, don't forget that constant c. This is 1/30th times, u is actually x to the 6th minus 5. This is still to the 5th power plus c, and that's where we can stop. We'll pause here for questions. Concept 11 suggests to do integration by parts here. I see two parts. I see an x and I see a sine 11x. If I follow our little liate, L-I-A-T-E, the thing we want u to be is x, the algebra. Then dv will equal everything that's left, which is sine 11x dx. Make sure when you do this, when I get down here, I've got all the parts are represented. I see x, I see sine 11x, and I see dx. That's all the parts that are here. Make sure they're all represented when we get done writing u and dv. From there, I know u, I need to know du. So I'm going to take the derivative of both sides. The derivative of x is just 1 dx. I also know dv, I need to know v, so I need to take the antiderivative of both sides. The antiderivative of sine 11x would be negative 1/11th cosine 11x. I'm going to pause here real quick and see if there's any questions. Now we'll just go ahead and plug this into the formula. Recall the formula is uv minus the integral of v du. That's what we're plugging into using these values that we have. I've got a u, a v, and a du value now to plug in. So this would equal u times v is negative x over 11 cosine 11x, that's u times v, minus the integral. I always write a space here for the constant when I go to this next step. So v times du, this part right here, v times du is negative 1/11 times 1. Well, negative negative is a positive 1/11. And then I have cosine 11x dx. So what I have here now is a simpler integral than what I started with. That's a good thing when we're integrating by parts. We like to see that happen. I just got to go ahead and finish this integral. So I'm going to keep the negative x over 11 cosine 11x plus 1/11 times whatever this integral would be. The antiderivative of cosine would be sine, but I've got to follow the chain on this 11x, so I'm going to have another 1/11 sine 11x, and the plus c should appear here. So if I clean that up, just multiplying this together, I have negative x over 11 cosine 11x plus 1 over 121 sine 11x plus c. And that will be my final answer. And we'll pause here for questions. Okay, we caught the 11x needs to be here, not just x. Okay, we're still doing parts here. I've got an 8t part and I've got an e to the 3t part. Light would tell us to use the 8t for u. Then dv has to be everything that's left, e to the 3t dt, and I've got all my parts. I've got u, I need du. The derivative of 8t would be 8 dt. I've got dv, I need v. The antiderivative of e to the 3t should be 1/3 e to the 3t. We'll pause here and see if there's any questions. Go ahead and plug this in. U times v, the constant would be 8/3. And then I would have t e to the 3t. That's u times v minus the integral. The integral v dv is going to have an 8/3 constant also. And then I'm going to have an e to the 3t dt still inside my integral. Remember, the only thing we pass through here is the constant. And that constant came from 1/3 times 8 when I did v times dv. So that constant passes through the integral. Just makes it easier to deal with as we go if we pass that through. So this will equal 8/3 t e to the 3t minus another 8/3 times whatever the antiderivative of e to the 3t is. Well, we've already done that antiderivative here, so we can go ahead and just copy that antiderivative back. I'll have a 1/3 e to the 3t again, and then plus c. All I really need to do now is clean up this multiplication in the middle here. So my final answer is 8/3 t e to the 3t minus 8/9 e to the 3t plus c. And we'll pause here for questions.